Perfect. Thank you. So first of all, thank you so much for all the people here. This is a really, really great initiative that we have with Women in AI. Thank you, Jimmy, for the warm introduction. This is the first ever Meetup for Women in AI. I'm so proud, and I want to say thank you to the speakers that they wanted to be part of this first initiative. So let's talk about farming with CLIP. So we have a lot of stuff to do with foundation models, and we will talk about how we can use foundation models in a responsible way. So if you want to access the slides, so you can scan this QR code and you can access and follow me on your laptop, or just take a look of this later. Join our community in this. If you want to keep this conversation, you can also join our community. We have a great community there. So a little bit about myself. My name is Paula Ramos. I'm a senior computer vision advocate lead at Voxel 51. And I'm an enthusiast of this kind of engagements that we have with people, but also educating people in AI. So there are a lot of content, there are a lot of things happening, how we can bridge the gap in between the technology and the usability of the technology. So reach out to me if you want to keep the conversation about that. So that is great. So let's jump in the topic today. So, this is not the future. This is a problem happening now. Every year, farmers face devastation caused by pests and plant diseases. An invisible enemy in the fields that cost the world over billions of dollars annually. This is insane. So, and this is not isolated. So if you think about every crop in every region, every farmer has a problem with the system. They need to keep up with the pace of the ecological change, climate stress, and species shifts that are also happening. So imagine now an AI that could recognize rare species, detect invasive pests, and understand life stages across 366,000 species without needing constant retraining. And we are talking about Biotrop. So Biotrop is the world's largest scale data set. And also Biotrop CLIP that can help us to use foundation models to go beyond cats and dogs, giving us new tools to operate in the real world scenario of agriculture. We are open. We have this data set that is open, is messy, and massively diverse. And this is what we need to do to believe that these foundation models can help us to support this kind of challenges that we have. Okay, to achieve this, we need something that is scale like nature. We need open data. We need generalist models and tools that can help us to understand both, just data, also the models. And today we will talk. We will talk about Biotrop. This word, the latest biodiversity data set, together with CLIP or fine-tuned model or CLIP for this Biotrop, and FiftyOne to prototype practical and scalable AI solutions for agriculture and conservation. So you could imagine, how hard is find some samples or images when you have a large scale data set, but you have a few labels. And this is what is happening with this Biotrop. So if you want to, I want to recognize, so Biotrop is a work that is done by a group of researchers in Iowa State University. So a large curated image data set enabling AI for biodiversity. And this is one of the main things that we have. So the data set itself has around 162 million of images with more than 366 K species. But it's not just having a species. We have a lot of data in that data set. So we have scientific name, taxonomy, hierarchicals, and also common names. We have, they have split the data set in multiple subsets. For training, for example, they are also training a Biotrop clip with 4 million images, also keeping the metadata and everything. So I think that is great. We have the three kingdoms. So we have animals, fungi, and plants. But also we can see a lot of stuff. We can see birds, we can see mollusca, reptiles, insects, and everything. How we can navigate this data set? This is the first question that we need to put in the. Imagine you're just trying to understand these 160 million of images with the species ranging. This is chaotic. This is really well organized, but it's also chaotic, rich, diverse, but overwhelming. If I want to be, try to find something there and try to isolate something or try to create a subset for training a specific use case. But this is where FiftyOne can also bring a structure to this. So let me show you how FiftyOne can work on that. I will show you three main examples, so you can take a look at how we can navigate these kind of large-scale data sets.
So Paula, I'm going to jump in here real quick. I think if you stop your video share, it might help with the bandwidth a little bit, especially if you're going to go into a live demo.
Okay. Thank you, Jimmy. Hold on. I need to find this one. Okay. Yes, I don't have a lot of bandwidth. Thank you, Jimmy. Let me know if this is better now.
So far, so good.
Okay, awesome. Thank you. Okay, let's continue on this. So let me show you how FiftyOne can help us with that. So the first thing that I want to show you is a video. A video that we have here, how FiftyOne. So FiftyOne is an application, so it's an SDK, but also it's an application that we have to explore the data sets. So let's see. Okay, yes. So here we have a view. So we have around 160K samples. So in the left side we have we have all the metadata that I mentioned before when we have fungi, animalia, or plantae. When we can select what kind of kingdom we want to see. This is in the label part. But also we can see a lot of metadata. We can also, for example, identify insects from these metadata and try also to take a look of this, what is going on with that. But not just that. So we can also gain some insights with the data set. We can calculate with the embeddings, we can calculate some indexes. So for example, uniqueness will show us how unique is this image in the data set. So we can understand, for example, in this specific scenario within insects, in animalia, how unique are those images. This is the first way that we can have for exploring data sets. But we can also explore this with a dashboard. So if we have the data set, we can explore with that dynamic and interactive plots how we can navigate the data set. If I, for example, need to create a dashboard where I need to add a categorical histogram, where I need to see the distribution of the data set, how many images or samples I have per kingdom, I can see that I have more in animalia, less in fungi, in the middle in plantae. So, and I also can touch those bars to take a look of what is going on with the visualization of the data. But, we can also add another kind of metadata in dashboard that help us to navigate interactively the data set. So, and you can see here that we can add multiple plots. I can touch the bars and I can just immediately filter and curate my data with the labels that I'm looking for. So in this case, I'm doing exactly the same thing that I'm making at the beginning, just selecting insects from animalia. So let's move forward for the next way to navigate this kind of data sets is about embeddings. So we have high dimensionality representation of the images with a feature vector, where basically we have the embedding. So it is difficult to visualize the embeddings in one single 2D plot. But when we reduce the dimensionality with multiple methods, we can see those dots in the plot. And this is why we have here the embeddings, for, with the dimensionality reduction, we are using a clip model for calculating embeddings, and also we are using UMAP for reduce the dimensionality. We can take a look of the clusters that we have. So these three kingdoms that we have, we can take a look of these images and where those images are located. And this is just the visualization. When we have the embeddings, we can calculate and gain insights with something that we call FiftyOne brain, where we have just, not just the calculation of embeddings, we can visualize as well, but we can also calculate similarity. We can calculate uniqueness. And basically making a vector search and having this capability with the model to have the similarity. And let me show you how this is there. So nature is messy. Our models are messy. So and we need to have better AI for monitoring ecosystems, pets and crops. So I'm really excited about this kind of models helping with the zero shot and low level scale these solutions. And a reflective foundation models in the wheel is that we need to be sure that we are in the real world. Basically these foundation models are trained with internet scale data sets. But we don't have a pollinator with Instagram account. So we need to be sure that we are taking care of this creation of the data sets. So, and we need to have the proper visibility of that. And this is the reason why Biotrop will open the window to that world, messy, real, biological grounded, and critical for food systems and ecological health. So beyond cats and dogs, this is another reflection for modeling ecology. So we have a lot of information, but maybe that information is not helping us for the real world scenario that we have in the farm, in a forest, in a fragile ecosystem, and we need to have more than that. And it's the reason why we have this Biotrove that includes more than 160 million images from iNaturalist. So, we can take a look of that. So we have here a leaf and a moth, but more than that, we have the class, the scientific name. We have the family pest, the pest family as well. So, and this is how we need to evolve these foundation models to serve science. So let's take a look of how we can also help us, speak the same language with the foundation models. Let me just open this. So we have here a way to sort by similarity. I already mentioned this. We have already the embeddings with the Biotrop clip. We can also include here a specific text. A moth on a leaf. That is the text that we are looking in the data set. When we execute that similarity with that natural language information, we can see this. So this is great, because if you think about as well, who are the users of these kind of solutions? So we need also to bridge the gap between non-technical people with technical information. So having this natural language interaction with the models is really important. So, and let me jump on this here. So we have, for example, this query as well, Cydia Pomonella. This is a scientific name. And I'm running this using the Biotrop, and we are able to find this Cydia Pomonella. But if you can take a look of that, these are not in a natural environment. This is coming from internet, but we have a gap. We need to see this in a natural environment and detect when this Cydia Pomonella is coming, because this pest is eating the leaves and the fruit. It is really important to understand when this is coming. So when we have this, we need to maybe improve the data set. So we are finding a gap in the data set, in a huge data set. We can use Cydia Pomonella, but not in real world scenarios. how we can fix that. And that is the next step. So how we can augment that data. So we could see maybe a lot of Cydia Pomonella classes or species. So we have all of those here, but maybe we are missing something. How we can fix that gap? And this is the way that we can fix the gap. So we can simulate, we can create synthetic information with the proper information that we already have. So we need to augment that data. So, and the way to do that is we need to put this species and this, for example, in this case, these insects close to the real world scenarios. How we can do that? So we are using NVIDIA Cosmos Transfer World Foundation model that help us supercharge biodiversity modeling. We are using more than 300 gigabytes of pre-trained weights, and we can run in multiple kind of models. We can put the Cydia Pomonella in a real world scenario. Even better, we can also create videos with this. So Cosmos Transfer generates samples, taxonomically consistent and ecological diverse. And if you want to take a look more about the NVIDIA Cosmos, that will be great if you can scan the. With this one, when we have a model that is not working well, it's because we don't know the data set, because it's training on lies. So we need to understand what kind of data we have and how we can bridge the gap with the final result that we need, the final result that we need to see in the final data. So for that reason, I want to close saying that we need to have this, we have this approach, data-centric approach or model-centric. We have been working in the model-centric approach for a while, but we need to reduce the bias and errors. If we move directly with model-centric approach, where basically we are adding more data, but we don't understand the data at that point, we still have this persistent bias. We increase the model complexity because we are adding more weights to our model. And we are also increasing the computational cost that we have. If we use the data-centric approach, we can reduce that bias, we can increase the data set quality, and we will be cost efficient. So, and data-centric AI approach is not optional, is what is happening, and is with Biotrop and FiftyOne can, help to solve these kind of problems. And for example, in this case, I want to showcase the model evaluation panel that we have in FiftyOne, where basically here I'm comparing the normal clip model and the Biotrop clip model. And we can see average and confidence. We can see F1 score. We can see how many incorrect samples we have. And as you can see, the trophies are in the Biotrop clip. That means that this is really useful and is really solving a problem that we have in a specific domain, that is biodiversity and agriculture. Okay. So we need AI tools for understanding context and domain diversity. From intelligent pest detection to biodiversity monitoring, AI must extend beyond common categories to serve natural world's complexity. So we are working on that. So I just want to let you know that Voxel 51, we are the main maintainers of this open source solution that is called FiftyOne, as simple as pip install FiftyOne. That's all. And we are making visual AI a reality, because you can take a look of what kind of problems you have in production. You can solve this just adding quality to your data set, and FiftyOne can help you to achieve that. So if you are interested to know more about that, so you can pip install FiftyOne, you can take a look of the notebooks that I create for this talk. So basically every single video that you saw here, I have a notebook running, so you can access the Biotrop in a friendly way and explore maybe other models that you have on your side. Join our community and attend our events. And this is really funny. We have a lot of things happening in the nature, even if we put a lot of efforts in AI. So this is happening in nature. A caterpillar can be a snake. Because they are this petition made me cry. So thank you all, and let me know if you have any questions.